Exercise 10.2, very simple exercise based on the theory which were discussed. The first question is find the magnitude of the following vectors. The first vector you are given a equals to I cap plus j cap plus k cap. So here components are 1 1 1. So it implies its magnitude equals to root of, your coefficient is 1 1 square 1 square 1 square. So this is nothing but the root 3. That's the magnitude of the first vector. In form of coordinates, if you want, you can write like this: 1 1 1, coefficient of I, coefficient of j, and coefficient of k. Second one there, second vector, that is 2i cap minus 7j cap minus 3k cap. So therefore magnitude of vector b equals to root of 2 square, which is 4, plus minus 7 square 49, plus 3 square which is again 9. So here you will get root 62. No need to put the value of this much, you can keep in this form. Third one, let's go for that. You are given the vector c equals to 1 upon root 3 I cap plus 1 upon root 3 j cap minus 1 upon root 3 k cap. So magnitude of c will be here root of 1 by 3, here again 1 by 3 whole square plus 1 upon 3. So this will be just 1. So therefore you can say that this is nothing but unit vector. Remember, this is a unit vector. Any vector whose magnitude is 1, it's called unit vector. So C is a unit vector, just for your information. Write two different vectors having same magnitude. That's question number 2. You can choose any vector. Let's take vector equals to I cap plus j cap plus k cap. Just now we did magnitude is root 3, and here b I just changed 1 minus sign like this, for example. So here magnitude of this vector is root 3, magnitude of this vector is also root 3. This is just one example. You can find many such examples, remember. Question number 3, third question. What is that? Find different vectors having the same direction. Same direction means what? Multiples, remember. So let's take vector a equals to, suppose I have taken I cap plus j cap plus k cap, and then I'll take its multiple. So I'll write 2i cap plus 2j cap plus 2k cap, right? If two vectors are multiples, then they are in the same direction. If you remember, we already discussed. If you recall, if two vectors are in the same direction, then they are positive multiples. So here you can note that vector a equals to some constant vector b, and where k is positive. That much you can verify. So therefore vectors, these are the required vectors, which are different vectors having the same direction. So the directions are same directions, remember. Here for this to here magnitudes are same. Magnitude of a and magnitude of b, these two magnitudes are same, remember. Okay, next question. Find x and y such that these two vectors are equal. Right, here one vector is this, these are the two vectors, vectors 2i plus 3j and x I cap plus y j cap in R2, remember. These two vectors are equal, means their magnitudes, these two vectors are equal, therefore corresponding components will be same. Corresponding components are equal, then and then they are equal, corresponding components are equal, remember, are equal. So therefore you can write x equals to 2 and y equals to 3, remember, right? Here component of I is 2, here x, here 3, and therefore we have this. Very simple question. Next one, let's go to 5th question. Find the scalar and vector components of the vector with initial point. So let me call that as A, whose position vector is 2, 1, and terminal point here B. Let's try it. Here it is minus 5, 7. Okay, so here this is a vector AB. You know how to write this minus this, if you remember. So minus 5, 7, we did this one in theory, and minus 2, 1. So this is nothing but minus 7, minus 5, minus 2, 6 here. So this are called scalar components, right? And if I express in form of in I and j, so minus 7i cap plus 6j cap. So what are the scalar components? Scalar components means just components. Scalar components means just numbers, minus 7, 6. And what else you are asked? Vector components means with ijk notation. Vector components minus 7i cap you can write, and 6j cap. Vector components in ijk notation, and scalar components just numbers, remember. Fine. This just I'm reminding you, if you remember, if you have vector A with position vector A, another vector with position vector B, then I have already mentioned in the theory, vector AB is given by vector B minus A, if you remember. Just if you recall, we did it. Fine. So that's what I've used here, remember. Okay. Next question, question number 6. Here in the 6th question, question number 6. What is asked? Find the sum of these two vectors. Sum of these three vectors, sorry, there are three vectors. So just add them, very simple. So vector A plus vector B plus vector C. Just add component wise. So you have here I minus 2j plus k plus, this is vector A. What about vector B? Minus 2i plus 4j plus 5k. And vectors this, what about that? I minus 6j minus 7k, right? These are the vector C. If you add them, this, if you add, it is 0i cap. 2j here, 4j, and here 6j, so it would be minus 4j. And what about this? This is nothing but here 7, 5 plus 1, 6, so it is just minus k. So therefore you are getting finally minus 4j cap minus k cap. If you want to write in form of components, you need to write 0, minus 4, minus 1 like this, remember. I is there, but the coefficient of I is 0. You know very well that. Okay. Now next here, what about next question? The next question is, so given this vector here, I plus j plus 2k, you want to get the unit vector in the direction of this, so you need its magnitude. What its magnitude? 1 square plus 2 square, which is 4, so you have root 6. So if you remember, we did it, required vector, required unit vector, remember, that is vector upon its magnitude, right? So what we'll get here? 1 upon root 6 I cap plus 1 upon root 6 j cap plus 2 by root 6 k cap, remember. This is just required unit vector. This is a unit vector. If this is a new vector obtained from the given vector and its magnitude equals to 1, which you can verify. Not difficult, remember. Next question, 8th question, question number 8. What about 8th question? Find the unit vector in the direction of PQ. So you need to get the vector PQ first. How do we do this? Position vector of Q minus position vector of P. What are the points here? Points are 4, 5, 6. Just have a look at the question. Minus 1, 2, 3. So 4 minus 1, 3. 5 minus 2, which is again 3, and 6 minus 3 is 3. This is vector PQ. Get its magnitude. So magnitude of PQ equals to root of this square plus this square plus this square. So you can take 9 outside, it becomes 3, and inside the square root it is just 1, 1, 1, which is 3 root 3, which is actually root 27. So therefore the required vector, that is, equals to vector PQ upon its magnitude. This is the formula, you know very well. So this upon this, you can write if you want in IJK notation also. So here 3 comma 3 comma 3 divided by 3 root 3. So 3 will goes away here. So it is just 1 by root 3 I cap plus 1 by root 3 j cap plus here 1 by root 3 k cap. This is the required vector, remember. Fine. 9th question, you are given two vectors, vector A and vector B. The question is, find the unit vector in the direction of vector A plus vector B. So to find this is a question. To find unit vector in the direction of vector A plus vector B. So what you need to do here, first get vector A plus vector B. You know how to do this. Get their magnitude, right? And therefore the required vector equals to, what will be your required vector? Equals to vector A plus vector B upon its magnitude. That's what you need to do. This is the required vector. So I'm sure this much you can do. Okay. Now next one here. Find a unit vector in the direction of this vector. So you are given a vector. Let me call that as A. Vector A equals to, you are given this 5 I cap minus j cap plus 2 k cap with magnitude equals to 8. Now we don't want unit vector, remember. So what I'll do, first I'll get its magnitude. Let me see what is the magnitude of this vector. So this is 5 square 25 plus minus 1 square, which is 1, and here 2 square, which is 4. So this is nothing but here root 30. Fine. Now here in this case, let's write in this way, required vector equals to, if I write vector upon its magnitude, then this vector will have unit length. Unit length means length equals to 1, but you want here a vector with length equals to 8, so I'll just multiply with 8. Got it? If you get this much, what you will get? You will get the vector with magnitude equals to 1 unit. But you don't want a vector with magnitude equals to 1. You want a vector with magnitude equals to 8. So we multiply this expression with 8. So 8 into, what about this? 5 I cap minus j cap plus 2 k cap upon its magnitude. Magnitude is root 30. So again, now the question is, you just simplify. That's a question. So 8 you need to take inside this. So 40 by 30 I cap minus 8 by root 30 j cap plus 16 by root 30 k cap. This is required vector here, right? Why I have multiplied with 8? That must be clear to you, remember, because we want a vector with magnitude equals to 8 in the same direction. That's why we are multiplying with 8, remember. Okay. Question number 11. Show that these two vectors are collinear. Collinear means what? Either they are in same direction or opposite direction, remember. Collinear, if you remember, we already mentioned, they must be parallel to some fixed line, remember. That's the meaning of collinear. So in another language, either they are in the same direction or opposite direction. So what you need to show? You need to show that they are multiples, remember. So your one vector, let me call that as I. 2i minus 3j plus 4j is vector A. The other one I'll call that as vector B, minus 4i plus 6j minus 8k. So just by writing these two, you must have realized. So here clearly you can see that vector B equals to, you can write minus 2 vector A, remember. You multiply this vector with minus 2, you will get exactly this, remember. So therefore vectors are in opposite direction, because here this is negative. Vectors are in opposite direction, and therefore they are collinear. Vectors are in opposite direction and therefore they are collinear. Therefore collinear vectors. Collinear means what? Either they are in the same direction or opposite direction. This much you need to show, remember. Next question, question number 12. What's the question number 12? Get the direction cosines. Direction cosines are nothing but what? Unit vectors, components of the unit vectors, remember, nothing more than that. So let me call this as vector A here, which is I cap plus 2j cap plus 3k cap, and therefore its magnitude equals to root of 1 plus 4 plus 9, which is nothing but the root 14. Fine. Now how do we write the direction cosines? You know direction cosines, if you remember, first component upon its magnitude. You can write small l, which was x by r, if you remember. R means the magnitude. Small m equals to y by r, if you just recall. And n equals to z by r. Z means third component. So therefore direction cosines will be 1 by root 14, comma, here what is y? 2 by root 14, comma, 3 by root 14. These are nothing but the direction cosines. If you want, you can write cos alpha, cos beta and cosine gamma. That symbol is not important, but you know these are the direction. This is simply unit vector, nothing more than that, remember. What you did, you are just dividing by what? Its magnitude to the given vector. Now next question, find the direction cosines of the vector joining these 2 points from A to B, remember. Okay, so you have here one vector starting from A to B, remember. So here vector AB will be, you know, B minus A. So what are the components here? If I write B minus A directly, it will be minus 2, just have a look there, minus 4, comma 4. These are the components. B minus A, B minus A, just have a look there, minus 1, minus 1, minus 2, minus 2, minus 2, minus 4 and this 4. Now get the magnitude of this, right? Get its magnitude, which is not difficult. You know 4 plus 16 plus 16. So how much? What's the magnitude here? You know this is just 6. Magnitude will be 6, and therefore direction cosines, this is what you are asked. Direction cosines will be minus 2 by 6, comma, minus 4 by 6, comma, 4 by 6. You can reduce it further. Just cancel the common factor and you can reduce to minus 1 by 3, minus 2 by 3 and 2 by 3. That way, if you want, you can write it, remember. Question number 14, that we'll do later on, so leave it right now. Question number 15, let's do that. Find the position vector of a point R that divides a line segment joining these two. Here, one point is this, P is this, ik plus 2j minus k. And what about Q? Q is given by minus I plus j plus k cap. This is given to you. Now the first question in the ratio 2:1 internally. Internally means you take positive ratio. Internally, remember. You know such things from 11th standard. So it's like this here. This is P, this is Q. You have one point R here which divides in which ratio? 2:1 ratio, remember. So therefore position vector of R by section formula here, by section formula, R is given by 2 into Q. Q is this position vector minus I cap plus j cap plus k cap. There is nothing to remember. You have just opposite side, remember. Okay, 2 into this plus 1 into this, 1 into we have P, that is I cap plus 2 j cap minus k cap upon m plus n, that's 2 plus 1, which is 3 here. So therefore R equals to, now just simplify, minus 2i plus I, that's just minus I, 2j plus 2j, which is 4j, 2k minus k, which is 3k, upon 3. So finally we can write R equals to minus 1 by 3 I cap, 4 by 3 j cap plus k cap. This is a position vector when line segment is divided by that point R in 2:1 ratio. Here in this case internally, remember. Sorry, here I suppose there is a little mistake. 2 minus 1, that's just 1 here. So you have 1 by 3, remember. Right? So minus 1 by 3 I cap plus 4 by 3 j cap and plus 1 by 3 k cap. Now here second question is in 2:1 ratio externally, remember. Externally means what? Point P is outside the given line segment and ratio is negative. So here the ratio would be, what's the ratio? That's minus 2 by 1, remember. So it's like this, for example, P is here, Q is here, then R will be outside this line segment, remember. So R may be, suppose here, for example, maybe this side or this side. This is just rough diagram. So ratio will be same here. Which ratio? 2:1. So therefore with minus sign, remember, 2:1 ratio with minus sign because you have external division. Therefore by division or section formula, the position vector of R will be, instead of 2 I'm going to write here minus 2 into the position vector of Q, I minus I plus j plus k plus 1 into, this is the only difference, remember, 1 into now position vector of P, that is I cap plus 2 j cap minus k cap upon, we have minus 2 plus 1, remember. So we are just left with minus sign here upon minus 1. This is nothing but here, what will be this? This is 2 plus here, this is nothing but the 2 plus 1, which is 3 I cap. What about this? Here minus 2 plus 2, so this is just 0. Here minus 2 minus 1, which is minus 3 cap. So therefore position vector of the point R will be minus 3 I cap plus 3 k cap. This is the required point that divides the line segment PQ externally. What's the difference in internal and external division? For internal division, ratio is positive. So your 2 is to 1, whereas here your minus 2 is to 1. That's the only difference. You know it from 11th standard. Okay. Next question. It's just the midpoint. Find the position vector of the midpoint of the line segment joining these two. So in the next question, you have point P. That's 2, 3, 4. Very simple question. Q here 4, 1 minus 2. Therefore, you know here midpoint of vector joining PQ here. The vector PQ equals to, if I call this as vector A, for example, vector A, and if I call this as vector B, then vector A plus vector B by 2. You know this, right? Just average. So 2 plus 4, 6. 3 plus 1, 4. And 2 the whole by 2. And therefore, finally we will get the 3 comma 2 comma 1. I wrote in form of what? Coordinates, remember. If you want, you can write in terms of IJK notation also. The same question you can write like this: 3i cap plus 2j cap plus k cap. Both are correct. Remember, whether I write in this form or whether I live in scalar form, both are same. Remember, this is just way of writing. So we have this 3i cap plus 2j cap plus k cap. Just midpoint, remember. Now let's do the last three. Okay, before I get into MCQs, let's go to question number 17 first. Show that these are the position vectors of the vertices of a right angle triangle. Okay, so we just use here concept of the Pythagoras theorem only, remember. So these are the three vertices. It's like this, remember. You have a triangle. A whose position vector is this. Point B whose position vector is this. And point C whose position vector is this vector C. Fine. So we need to get the side vectors. AB, BC and AC are CA. So here sides are this. Sides are this. One is vector AB. You know how to write this, right? B minus A, that is this minus this, minus I cap, this minus this, plus 3j cap, this minus this, plus 5k cap. I repeat what I did. You know, when you write vector AB, then you need to write B minus A. I suppose I did reverse way, no? Okay. What you need to do? B minus A. So I did other way around. Here it's not important, but let me correct it because we need the magnitude. B minus A. So 3, 2 minus 3 minus, then you have minus 1 plus 4, which is 3, and this one 5. This is vector AB. Vector BC now. That is nothing but what? C minus B. C minus B, which is minus I cap. This is nothing but the minus 2j cap, and this is nothing but the minus 6k cap. I repeat what I did. Vector BC, that is C minus B. C minus B, I cap, this minus this, minus this will be plus, so minus 2j, and this one. And finally you can write AC or CA. That's not important. Vector AC, that's C minus A. This minus this, minus 2i cap, C minus A, this minus this, so plus j cap, and here C minus A, this minus this, so minus k cap, remember. Fine, this is vector AC. Now we'll get their magnitude. So what's the magnitude of vector AB? Which is root of 1 plus here 9 plus 25. So this is nothing but root 35. What's the magnitude of BC? Magnitude of BC, that's 1 plus 4 plus 36. So this is root 41 here. And magnitude of vector AC. magnitude of vector AC, which is root of 4 plus 1 plus 1, so which is nothing but the root 6. So from this 3, it's quite obvious that magnitude of vector AB whole square plus magnitude of vector AC whole square equals to magnitude of BC the whole square, right? 35 plus 6, 41, which is this, and therefore BC will be hypotenuse, and therefore triangle ABC is right angle. Right angle, remember, it's a right angle triangle. Just refer example number 12. It's a copy of this example 12. It's the same question. Just have a look for it, you will realize. The 18th MCQ, you are given a triangle here, vector A to B, then we have here B to C, and then A to C here, remember. So by triangle law, this is always true. By triangle law, this is always true. Vector AB plus vector BC equals to vector AC. This is always true. This is same as, you can write like this, vector AB plus vector BC. I'll take on the left hand side. So it's minus vector AC equals to null vector, right? This is always true. This is your option B, you see, this is true. Fine. Now you can just change the direction here. So the same one, you can write AB plus BC plus here CA, remember. I would change the direction, so this will be opposite. This is null vector. This AB, BC, CA is vector A to A. And this is nothing but the option A, which is also true. Now here, over here, if you just look at it, option D, if I change the direction, if I write vector CB, then you have opposite sign. Plus vector CA, which is null vector again. This is option D. So these 3 are true. Therefore, third option, if you look at C, is not true. This is just based on, triangle property. MCQ number 19. A and B be two collinear vectors, remember. Vector A and vector B are collinear. Right. As I have told you, collinear vectors means what? One must be multiple of the other one. You can write K vector B, remember, where K is any scalar. Scalar means number, K can be any scalar, remember. So here first one is true, remember. First one is true. Which are incorrect, that's you are asked. First one is true. One vector is a multiple of the other one. Look at it, the first one. B need not be true. Not necessary, remember. It's not necessary that K is always plus or minus 1. Go to option C. Respective components are not in proportion. No, that's also wrong. Respective components are always in proportion, remember. So C is also not true. Both vectors have the same direction, not necessary. Vectors can be in opposite direction also. So B, C and D, these 3 are not true in general, remember, not true. So the correct answer is this, B, C, D. You are asked which of the following are incorrect, remember. So B, C, D are incorrect. The first one is true. Collinear means they are always multiple of one another. Not necessary always this K or that lambda must be plus or minus 1. This is never true, remember. They are always in proportion. Respective components are always in proportion. And they may be in opposite direction, not necessarily in the same direction. So B, C, D are wrong. Fine.